Dear students, let's begin the third module of radiation physics. The third module is radiation quantities, units and dosimeters. Importance of dosimetry. It is a universally accepted fact that radiation causes damage which can range from a subtle cell mutation in a living organism to a bulk damage in a detector. The type of damage depends mainly on the type and energy of radiation and the type of material. This damaging mechanism of radiation is sometimes exploited for the benefit of mankind. For example, in the case of radiation therapy of cancer, where the cancer cells are targeted and destroyed by radiation. Unfortunately, the damage caused by radiation cannot always be easily quantified. Some types of cell mutation caused by radiation take years to develop into detectable cancer. How do we then find out if a particular individual or equipment has received a high enough dose? And there have been extensive studies to determine the safe radiation levels for individuals, radiation workers, and equipments using statistical inferences of the damage data collected over a long period of time. And based on these studies, standards have been set up for maximum allowable dose to humans. So radiation is capable of causing damage to both living and non-living things through different processes. That the severity of such damage would depend on the amount of radiation absorbed by the material and also on the intensity of the radiation. One such effect is a mutation of cells where even low levels of radiation can cause permanent damage. Apart from cancer, exposure to high radiation can also cause severe skin burns and tissue damage. In medicine, radiation dose calculations are routinely performed to minimize the harmful effects of radiation. As the amount of radiation is an important factor in quantifying the possible damage to material, therefore, the terms radiation exposure and radiation dose have been derived. We found that both living and non-living things get affected by not only high levels of instantaneous doses but also by low levels of sustained doses also. The term dosimetry has been used to refer the measurement of dose. Radiation causes damage to the medium it passes through by depositing energy to the medium. And this damage can be acute if high level of dose is delivered in a short period of time. And in such a case, the dose delivered per unit time is so high that the material does not get enough time to repair the damage. The acute damage always depends on the time integrated energy deposited by radiation. The term dosimetry has been used to refer the measurement of dose. Modern dosimetry includes the measurement of dose rates also. Next is about the units of activity. Smaller units such as millicurie and microcurie are also used to measure activity. So 1 curie equals 3.7 into 10 raised to 10 disintegration per second. 1 curie equals 3.7 into 10 raised to 10 disintegration per second. Then 1 millicurie equals 3.7 into 10 raised to 7 disintegration per second. And 1 microcurie is 3.7 into 10 raised to 4 disintegration per second. Becquerel, denoted as BQ, is the SI unit of activity and it is equal to 1 disintegration per second. Next is about the exposure. Exposure is denoted using X. Exposure refers to the radiation quantity measured in terms of ionization in air in a small volume around a point. Exposure is a source-related term. Exposure is defined as a total electric charge, that is either plus or minus, per unit mass that X-ray and gamma ray photons with energies up to 3 million electron volt generate in dry air at standard temperature. It is a radiation quantity that expresses the intensity of radiation delivered to a specific area, such as the surface of human body. The exposure quantity X is based on a response produced when radiation interacts with air. Exposure is defined as a charge dq produced per unit mass dm of dry air when all the electrons liberated by the incident photons are completely stopped. And mathematically it can be expressed as X equals dq by dm. Its unit is joule per kilogram. Since the photon interacts with the charged materials are very different from other particles such as neutrons or alpha particles, therefore exposure has not been found to be very useful in characterizing the damage due to other types of radiation. Exposure can be expressed in a unit of Röntgen. Röntgen is a measure of exposure due to photons only, that is X-rays or gamma rays, and it is based on the amount of ionizations they produced in air. Exposure from an X-ray source obey inverse square law, and one Röntgen shall be the quantity of X-ray or gamma radiation such that the associated corpuscular emission per 0.001293 grams of air, which produces in air ions carrying one electrostatic unit of quantity of electricity. It can also be defined as 1 Röntgen is the dose needed to ionize and produce 2.58 into 10 raised to minus 4 coulombs of positive and negative charges in 1 kilogram of air. Since it is not applicable to all tissues and represents dose only due to photons, it is now not widely used in dosimetry. So 1 Röntgen can be expressed as 2.58 into 10 raised to minus 4 coulomb per kilogram of air. Next is about karma. Karma stands for kinetic energy released in the medium, which describes the initial interaction of the photon with an atom that takes place in the medium. It is also called as the kinetic energy released in air, or kinetic energy released in material, or kinetic energy released per unit mass. Kinetic energy released in the medium describes the initial interaction of the photon with an atom that takes place in the medium. When radiation interacts with matter, the uncharged particles such as photons and neutrons transfer kinetic energy to the charged particles such as electron and proton. Karma is a measure of kinetic energy transferred to the charged particle. It is defined as the sum of the kinetic energy of all the charged ionizing particles liberated by photons in a material of unit mass. The unit of karma is joules per kilogram, and the SI unit is gray, and the special unit is rad. That's all. These are the references. Thank you.